In this video, we're going to talk about this absolutely epic tool called regression that can help us write equations of any type of function that we want, as long as we're just given a couple of points on that function. Regression is a tool that whenever we have a bunch of points, we can write an equation that matches those points. And Desmos makes this really easy. If we click add an item and we want to add a table, we can add whatever table that we want. So let's just say like this. And now that we have that, we can click on this add regression button to the left, and it'll tell us exactly what that equation is. This drop down will tell us exactly how we can change this equation into match any other equation that we want. And this r squared value will tell you how accurate that equation is to matching those points. So let's do an example. So this time we want to write a quadratic equation that matches those points. So if I click on plus and add a table, I can add -1, 8, 2, -1, and 764. And now I can click on my add regression. I don't want the linear, so I can click this drop down and make it into a quadratic. I see that it's a perfect match with my r squared. And so my equation would just be this: y equals 2x squared minus 5x plus 1. In example 2, we're given a table, and we're told that our x column is a bunch of time in months, and then our y column is how much revenue some company is making. And so we want to first write an exponential equation that matches this, and second, we want to predict how much they're going to make after 50 months. So let's go ahead and add this table, and let me do that real quick. Now that I have that, I can click on my add regression. And this time I'm told I want an exponential regression. And it's always good to click this log mode whenever we're working with exponentials, because as you can see, it makes it just a little more accurate. And so here's my equation. And now I want to predict how much after 50 months. We can actually use function notation to work this out. If we click on this, we can get the equation down here. It'll copy it for us. If I take out y and replace it with f of x, now it recognizes it as a function, and I can type in f of 50, and I can see that after 50 months, we can predict $15,886 dollars for our, or millions of dollars for our projected income. Let's write an equation now that can best match this line. And so I see I'm really given a whole bunch of points. Any 2 points on this graph will work. But I see the dots at 2 points specifically. So let's just go ahead and add those. That first point on the left would be -2, 6. And the second point on the right would be 1, -4. Now let's add the regression. I want it to be a linear function because it's a line. It belongs to our linear parent function. And I see that it's a very accurate equation, but I'm given this in decimals, but I want it in fractions instead. So what we can do is we can click on regression options, and we can export this as a custom regression. When we're working with this, m and b are the two numbers that are given to us. M is my slope and b is my y-intercept. And what I can do now is I can type in m, and it'll tell me what m is. But if I click on this button here, I can now convert that to a fraction. And same with b, I can convert that to a fraction as well. So my equation would actually be y equals -10/3x minus 2/3. Using the r squared value, we can also figure out what type of function each table is. So let's figure out if these are linear, quadratic, or exponential. So let's start with the first one. If I add the table, I can do 0, -2, 2, -8, and 5, -64. If I click on my regression button here, I see it's definitely not a linear function because the r squared is not close to 1. But I see if I click on exponential, that r squared is 1, so this first table is an exponential function. We can also just come up here and change change this to be -2, -8, 1, 1, and 10, 28, and that'll be my second. It's definitely not an exponential since my r squared value is pretty low. Let's check linear. When I click on linear, my r squared value is equal to 1, so this second table is a linear function. And my last table is going to be -5, -81, 2, -4, and 3, -18. It's not a linear because it's not equal to 1. If I click on quadratic, I see that my r squared is now equal to 1, so this last one would be a quadratic function. I hope you had as much fun as I did learning about how powerful of a tool the regression tool is in Desmos. Good luck in your practice, and I'll see you in the next video.